he catches up, then we'll go. We'll be a few minutes early for our break. It's an easy thing to do when we're doing multiple RAID arrays and we're doing complex RAID arrays to accidentally click on the wrong item. It happens every day. It's my biggest warning, is always having to double check. It would be better if they isolated it. Like when you create the RAID array, can you make a separate tab? And then that way it's not conglomerated with all the other ones, like I'm only working on this subset. And they don't have that. I mean, it's getting close to 2,000 there. Oh, 114, okay.
I wonder why it was so fast.
Huh?
I wonder why it was so fast.
Yeah, because you did a single file. And the single file got you there in 1/3 the time. So make sure you stop it when you get close to 2,000 so we don't have 10,000. All right. Okay, and then you should have an extra found files underneath the RAID array configuration. Double click on that, and then hit the size column twice, and it'll put the big ones at the top. Okay. Do you have a 632 now? Yep. All right. We're in good shape. All right. Jonathan left. I'm waiting for Jonathan to come back. Okie dokie. So now what we have is 632. Everybody, we'll just look at 632. And so if you double click on it, it will open it inside this tool. Now sometimes corrupt pictures don't open and you have to extract them and then use something that's a little more versatile than their tool. So you can use different things. There's several free programs that'll do it, but you would just have to highlight whatever you want to extract, put them on the hard drive, and then open them with a different tool, or look at them in a hex editor. So obviously we don't have the array right. So we obviously have something wrong. So the first question I have, to make sure that we have all the drives and we have the drives in the right order, that's the very first thing I would try to solve. So the question is, inside of this picture, are all the parts of this picture belong to this picture? Do all the parts of this picture belong to this picture? So that's pretty important to know, to make sure that we've got all the right drives, we got them all in the right order. And so the first thing we're looking for is to make sure all parts look like they belong to this picture. And again, the further you get away from something that's wrong in a dithered algorithm, the worse the colors are going to get. So you've got to start seeing through the colors or the layout or what that content is, because it'll just look worse and worse as those bytes have shifted. So the algorithm is actually, in the beginning of part of the JPEG algorithm is how highlighted the color is going to be, what the contrast is, things like that, and then it has the dithered algorithm itself. So you'll see that breakdown. So that's the first question I have, is if they all look like that they belong to this picture. Everybody good with that? Yes. All right, so let's close this one and let's look at another one. Let's look at the next one. Everybody at 103? Let's look at 103. So 103, do all of the items in the picture look like they belong in this picture? Yes. So then my second question would be, so if you're looking at the very top row, because our algorithms were always 1, 2, 3, and then 4 or 5, depending on how many drives we had, and it would rotate, right? So then you have your parity. Then you have the next round. So if you have 3 drives, you have 3 rows, then it repeats again. So keep that in mind. You've got 1 set, 2 set, 3 set, then it repeats again. So this is actually probably going to be close to 2 of these pieces together. So that's when you start getting it rotating through the cycle. So the first and the third row are going to look similar, and the middle is going to be wrong. Okay, so if we had 5 drives, we've got 5 rows. We have the same number equal to the number of drives that we have all the time because of the rows. Right? Everybody okay with this? No? Yes, no. Make sure you say yes or no. Yes, good. However many drives you have is how many stripes you have. So if you have 5 drives, so in 3 drives, it's every third one, then repeats. Right? So if you look at, it's kind like, don't do what I do. So we have 3 drives. So we have 3 rows. So the 3 rows at the end after 6, the next one is this one again. So the next row is this block all over again. All over again, all over again. So it's going to repeat the process all the way down. If I have 5, then I've increased this triangle by 1, so I've got 1 more. So 4, 5. So I'll have 2 more altogether. So I'll have 5 slices before it repeats again. So you're going to get this top row as a repeating process, 3 down, 5 down, however many drives down you have. Okay? So when we're looking at this picture, we'll go back to where we were. When I'm looking at this picture, what we're really seeing is a repeat performance. Now, every time that it repeats, if anything is messed up, it's skewed a little bit more, and a little bit more, and a little bit more, because every one of them is a consequence of the previous one. And so you'll have slipped data, bit slipped. Does that make sense? Bit shifted. All right, so if you're looking at this picture, the next question I would have, if you know that this picture is broken up into the columns, this is literally the data from drive 0. This is drive 1, and then this is drive 2. Everybody understand? Do I have all of my drives in the correct order in this scenario? Huh?
Looks like everything kind of lines up like 86.
Right. I would initially believe, because the top row, and it's the only thing I normally look at right away, is the top row. My eyes always go to the top. Now, understand, we're talking about hardware with an operating system sitting on top of the hardware. The operating system starts things in clusters, so every 8 sectors is together. It is completely possible that when we get to a spot where a picture is, it wasn't on drive 0, the beginning of the picture was on drive 1. So it is possible, because of where the picture is in the cluster, you could be on drive 1, drive 2, and then drive 3 be wrong because drive 3 is in the other order. Does that make sense? We don't know where we found the beginning of our picture. We don't know which one it is on. Does that make sense? So this is why I take a sample, because this one's right, but it still could be wrong based upon the fact that I've flipped somewhere else onto another cluster. So let's close this one. Let's look at the next one. Does anybody have 14? Let's look at 14. So same kind of thing. I'm looking at it. I'm saying, all right, so color is shifting. I can see the beginning of the picture. I can see the beginning of where this is supposed to be. This is a picture. It's not a coincidence that there's a picture frame and there's a picture frame, even if it has a different color. And then the top looks okay. Does that make sense? So again, do all the pieces look like they belong in the picture? It's harder to tell, but yes. Same thing for the next one. Let's go. So I'm really literally taking a sampling and I'm looking at all of these samples, and usually by the time I get to the 4th or 5th one, I got a pretty good idea. And after you've seen them enough, and I'll promise you this is what will happen, eventually you'll get to the point where you see them enough that you know exactly what's wrong with the picture, you know exactly which order of the drives it is, or you know exactly the algorithm, because you'll start seeing a pattern. And the pattern will start looking the same for everything that you do. But if you don't do it live and you use automatic tools, again, they were not available up until 2011 to solve these problems for you automatically. If you just say, I'm lazy, I'm going to push a button and I'm going to go home, have dinner, and tomorrow's going to be solved, you'll never get better. I promise you, you'll never get better. If you do this, you will be able to beat all of the automatic programs. The automatic programs will not be able to solve this as fast as you can. And when you get 16 drives in an array with 4 terabyte each, it will take it a week on automatic programs to solve the problem. And you might be able to solve it in under an hour. Everybody understand what I'm saying? So do this and start looking at them. Even though you might already think you've seen enough, I would still look at one more. So close this one, look at one more. And I'm begging you, if you were going to work for me, I'd make you do it. I'd make you do this every day until all of a sudden in your mind's eye you saw what the picture was supposed to look like. And then you know exactly what the organization is. So you're sliding the squares on the puzzle. How do you get them there faster? And people who play those square puzzles, they get better and better at it. They literally are to a spot where they go and then they're done. It's like a Rubik's Cube. They're over. And you need to be that with a RAID array. Do all the items in the picture belong in the picture? Yep. Okay. Does the top row look like it's intact, look like it's correct? Yep, and then this one rotates through, so even if that slice, so you can tell that this slice began at a different cluster on another drive. I see that right away. It actually started on the second one. So this is the second row, and so technically it is slipped, but everything that's supposed to be there is there. And that's why this one doesn't look like, again, don't do what I do, like, that's why that one does not look like this one. Because we started on that one here in the cluster. So where the clusters were, it picked up for that photo, it picked up at that position. And on this one, we're at the beginning of that cluster. Does everybody understand what I'm saying? You can see it as you start going through it. So what's the next one? Close that picture and go to the next one. What is the next one?
633.
633. So again, we may have started on another offset of the cluster. Now we're at the tail of one of the, so this would actually be row 3, and then row 1 repeats, and then so on and so on and so on. You see what I'm seeing? And next one, you get to where you can see these. Now again, once you've had enough experience, it'll start to look like you can figure it out. This one starts correctly, then this is actually row 2. So where the location starts, this is actually legitimately 1, 2, 3. So it's 0, 1, and 2, and then these are 3, 4, so on and so on and so on. Good? Then it loops back, does it again. Everybody think everything belongs in that picture? Yes. All right. So we know we're wrong, but we know we're partially right. And I will not kid you. Like, so I'm closing this picture. The very first thing I want to do is I want to back out of what I've got. I've got my idea. I know where I'm at. So let's close by right-clicking on the tab. You want to close just this tab. This stops you from making a mistake when you recreate something else. Okay? So make sure you back out and you get rid of the junk that you had before. Now, I will tell you this. There is a bug in our studio. I know all the bugs. I know where everyone is, and I know exactly what it's going to create. But there's only one that's critical to this process that we're doing over and over again. I don't know when it happens, and I don't know what causes it to happen. What I can tell you is this. I created this extra found files. And if I go back to the RAID array itself here, and I make an adjustment to this stuff, it will change it automatically on the fly, and it will modify the extra found files by replacing those things in the new order that I have done them. And then I can go examine that without rescanning. And I don't know when and why it happens, but at some point in time, it never makes that change again. So you keep making changes, but every time you go look at the array and your result, if you kept that, it stops changing. It stops working. And you don't know when that happens. So you'll be working on a 16 drive array, and you'll have a lot more things that you'll have to track. And so my simplest solution is this. If you want to avoid the bug, and I know it works, people will always come back later and they'll email me and they'll be like, you know, if you just don't do that, it'll automatically make those changes for you. Yes, it will. But eventually, for some reason, this bug does not reorganize the data, and all the data that you're looking at now is not representative of your actual result.
Maybe the loop breaks.
I don't know what breaks, but I know I've been in very complex situations and I thought it was working and it wasn't. And then I've gone back and figured out that that's what it is. So here's what I do every time. If you just do this, you'll never trigger the bug. It will solve all of your problems. You come back up to your virtual array. Make sure you've highlighted your virtual array. Right-click and get rid of the word that says remove scan information. You want to delete your scan information you already created. If you remove your scan information, say remove, then it puts you back in your original state. Surprisingly, it still caches some of the data, but it will rebuild faster the second time you do it. And most of the time, it'll rebuild faster the second time you do it, but it'll always work. From here on, every time that you do it, always destroy the information you just created.
So it's kind of like the spar where it remembers the sectors and then it just goes over quicker.
Yeah, whatever it's previously, I think it's just cached in memory. I think it's just, and in the 64-bit version, you got more memory, so there's more there. So when you start, sometimes it'll just already be that far out, and all of a sudden 2,000 pictures will appear. And so, and every once in a while, it won't. Every once in a while, it'll start all over again at the beginning, and then all of a sudden, you'll be, so there is a bug somewhere. I'm not sure what it is, but I know if I do this, I never see the bug. It never causes my problem. Okay? So now here's the thing. We now know some information. So the first thing that we know is our drives are in the correct order. So we know which one's number 1, and we know that the other 2, we don't have to swap them. We have verified that they are in the correct order, right? So again, this is one thing that I do, and I am not joking. If you do this, you will save yourself a lot of effort. If you were to examine your drives, I have 3 drives. I have a RAID 5, so I know that this is the layout of what I'm going to be doing. I know that the controller now, I know, and always if you're looking at money, you'll know the difference between a right array and a left array. And so we know we do not need a right array. It will not be a right array. It's always going to be one of the choices of a left array. How many choices do we have? 2. We have 2. 2 as a possible option. So we have left synchronous and left asynchronous. Those are our 2 possible choices. Okay, so I literally whip out a yellow piece of paper. I write them all down right then and there. I write, okay, here's my choices. I know I have drive 1 and 2 and 3. I know the order right now. Now, I would have had, if I didn't know that, I would have this as a possible thing I could swap. Okay, so my options would have been on this one, only 2 options. It would have been 1, 2, and 3, or 1, 3, and 2. Those are my only options, right? So starting right away, I have that as the first choice that I have to deal with is the order of the drives so I can get my pictures on the first row correct. Then the second choice that I have to deal with is and I choose them by the number of them. How many options do we have in slice sizes? Like 20, like 15, something like that. So if we had those choices, now it may not really be that. Here's the other cool thing that I found out. If somebody tells you the brand of the controller and you go look at the spec sheet of it, they will tell you what is possible. So even though you can set some controllers to 2K, 4K, whatever, most controllers only have 4 settings. They only will either go 32, 64, 128, or 256. Most of them won't do very many more. All the IBM ones only have 4 choices. So you don't even have a whole selection of your possible choices. Even though we have it in software, they don't have it in the hardware. So you may have 16, 32, 64, 128. You won't have all of the choices. So most of the time, and I know I've never seen a 16, I've never seen an 8. So I've seen a 32, a 64, a 128, a 256, and a 512. That's all I've ever seen, except for the weird one that's 512 bytes. There's the one that's 1 sector. So those are the only possible choices that I've seen. So we only have at most 5 of these. I will tell you that almost always you will only see these 3. 128, 32, 64. Those will be the only ones that you'll see. So I'll start at 64, then I would go up to 128, and if that didn't work, then come back down to 32. So if you're looking at your possible choices, these are the orders. Then I have left asynchronous. So now I've got 2 of these with left asynchronous. Then I have 2 of these with left synchronous. Right? So I've got 4 there using 64K. So that's 4 options. Altogether, that means I have less than 12. I have 12 possible options. If I do this test 12 times, one of those will answer my question. Does that make sense? Even if you didn't even know, even if you never made a correct assumption, even if you never even looked at the picture and could figure it out in your mind, do all 12. If you just do all 12 of these possible choices, then one of them will work. And I could do 12 tests in under an hour. Everybody understand where I'm going with this? So you could be dumb about it and just do them all. And I beg people, like, I guess one day I'm just going to have to sit down and write. I started out as a programmer, so I know how to write code. I'm too lazy to do it with all the other stuff I have going on. But you could literally write a program that just says, run all 12 and give me a picture from all of them. And then you can just click on the ones that are right. And then it'll tell you what your algorithm was. That would be awesome. I mean, we have automatic programs, so nobody's probably going to do that. But you could literally just run all your algorithms. So if I redid this piece of paper and made notes, that's what we would be looking at. 1, 2, 3. I already know the drive form. So I have LA and LS, 64, 64, 1, 2, 3. And then I have 1, 2, 3. And then it would be LA, 128, 1, 2, 3, L, A, 32, and then the same row, but doing the same row with the with LS, right? LS, and then 128, and so on and so on. Everybody good so far? So now, once I know anything about the array, I've eliminated half of the options. So, however many drives you have is the only number that it rotates you through, and once you've got that answered, then you've solved it. So, now, in this array, right now, I want you guys to play with it. Do exactly the same process I did. You have two other options to play with, so solve the array. So looking at the options of the options that you have here, and your next option is here. So you guys pick something, make a change, go do the scan again, and do it until you solve this array. So that's your lab right now, is to solve this array.
How do you reorder the drives?
So you can drag and drop them, but I prefer not to. What I do instead is this. If you highlight a drive, you can say move up, and so it'll reorganize them. So you can say move up and move down, and I find that to be better than the drag and drop process, because every once in a while the drag and drop process didn't work exactly the way I expected it to. So you can move them around based on their position.
Is there any clue if they're just dark and out of focus?
Well, you do get used to seeing what they are in those processes, but again, if you wrote down all of the options and you keep running them, oh, that's a thumbnail. You're looking at the tiny pictures. If you look at tiny pictures, a lot of times they'll work, and so that was actually a Sony camera back in the day. And so you're looking at all these little tiny pictures, do the big pictures. So go all the way to the top and do all the big ones. And so if you're looking at tiny pictures and they're below, so if I have a 32K slice and you look at a picture that is, see, so you have a solution. So it is impossible for you to have a 2 meg picture that is wrong because it's bigger than all of the slice sizes. Does that make sense? Mm-hmm. So once you got the solution, you know if you have a picture, under all circumstances, there may still be corruption. Something happened on the array, a virus ate something, or something else happened. But you know if you have a 2 meg picture, you know that you have your slice sizes correct. You may have an array where it was rebuilding and you have half and half. So that has happened before too. I can see it usually because then half of my pictures will be correct, and then all of a sudden I'll have a bunch of pictures that aren't correct that can't be wrong if the first one was. Does that make sense? So
It's just one change.
for that, yep, there's just one change. But like I said, even if you wrote them all down, you know enough to know there's less than 6. So right, so one of those is right. And while people tell you there might be 74 possible combinations, they're wrong. They just think there are that many items that are out there because they don't understand the layout of the RAID content. So
You would just reorder them and rescan it and do the same thing?
yep. Yeah, if I didn't have the row in the top, the correct row, then I'll focus on that and I'll keep reordering the drives. And you know, it's a problem if there's 16 and you don't know what they are. I'm hoping most of the time that people with 16 drives wrote down the drive when they pulled it out. The only other problem I've run into is this. So people who write down the numbers don't always know that the connector on the RAID array is done in pairs. And so what you'll have is you'll have 0 and 1, and they wrote the numbers down backwards. So they'll write 1 on the wrong drive and 0, and what ends up happening is every pair is the opposite. So not all of them are wrong, they didn't slide the numbers. What happens is 0 and 1 are backwards, 2 and 3 are backwards, 4 and 6 are backward, you know, and so on and so on. Like 5 and 4 are backwards. So it turns out they're in pairs, and it's because the connector on them was in pairs of a 0 and a 1. And when they went to the chassis, they didn't realize that they weren't sequential. They matched the chassis numbers, but they don't match the internal drives numbers. Does that make sense? Mm-hmm. So, because all of those, whenever you got that, like the Adaptec that I showed you, all of those are in pairs. And so the controller's in a pair, but the chassis is just a big box. They just plugged all the cables in, and when they reinitialized the array, it works fine because that's where it came. But when they pulled the drives out and they sent them to you, they were misordered in pairs. So, but you can even if there's 16 drives, to get the top row correct, you'll just be slowly building your correct image as you go through the process. And so you just reorder all the drives till you figure out the best possible solution. And if you only focus on one thing at a time, don't get crazy and start changing everything else. Once you change 2 things, you can no longer tell. So if you make 2 changes instead of 1 change, you cannot tell what the difference was. So always make 1 change at a time and look at it. Make 1 change the next one and look at it. Okay? It's like any other scientific process. Don't do 20 things and then blame it on 1. So it will not work. So you need to do them 1 step at a time. So I've been doing this way longer than 20 years. I used to do this as the managed IT guy when Dell used to mess up all of the servers. When tech support would be called, they would mess them all up. And I've had to reassemble many, many servers that somebody else messed up. Sometimes that's how I got the client. The dude who is their IT guy failed, and he couldn't get anything running. And it was way more complex than he could. And so they call around to try to see who they can get over there. And so I'd be the guy who show up, and I'd fix it. So, and I'd get a corporate client again. So, and when I sold my company, I sold 300 clients. And I had contracts with all of my clients. And that was the worst part of selling your company. If you have contracts with your clients, they're prepaying you. And now you've got a pile of money that if you sell your company, that's an asset of the company. So you basically have to give the money back. Right? So that's the worst part of it if you're in that situation. Like, oh yeah, you feel like you have $64,000 over here. But when you sell your company, that $64,000 was for pre-existing contracts that you're selling to the new company. So you got to give that $64,000 or count that in your sale. So, all right, everybody good? Everybody solve it? Okay, now, RAID 0. In the directory above the RAID 5 directory, there is a RAID 0 directory. And I want you to solve the RAID 0 directory. The majority of RAID 0s that I get in are 2 drives because those are the smart people. The other ones are 4 drives. I seldom get one that's like 3 drives in a RAID 0. It's always either 4 or 2. And so there is a 2-drive RAID 0 array. Now, the next thing I would tell you is every time that you use RStudios, there's going to be a little bit of memory that's leaked into your system, and it only goes away if you close the program. So if you're doing like a giant array, it really is easier if you just close the program and then reopen the program and it starts all fresh again with no memory, no nothing. So you should get into that habit, is really a good idea. So if you close RStudio, open it again, and then do RAID 0. So I want you to solve that array, and after you solve that array, I'm going to show you the other tricks that you can use for the software.
Oh, just 2.
Yep, there's only 2 in this one. Most of the time when you get them in, like I said, it's going to be 2 or it's going to be 4. I mean, when you use RAID 0, how many drives are you putting in yours? Just 2, right?
Just, well, I used to use 3, now 2.
Yeah.
If I've got 3 in there, how do I get rid of one?
You right click or click on it and you can say remove. There's a button right there that says remove. You'll be amazed when you start doing RAID 0s how easy everything is. It becomes just like an overnight sensation. You get paid a lot of money just to do quick and easy 2-drive, 4-drive arrays.
How do you start to scan again?
You right click on the array itself. So you right click right here and you highlight scan, and then the scan process will start.
for 2,000?
Yeah, over 1,000 or so. It's you'll find too that RAID zeros are easier to see the samples because there's no parity. So they're just raw data. There's nothing else. So you don't always need as big a sample for RAID zeros, but you know, it's up to you how many that you want to look at in the process. Because those are even closer to the square puzzle thing, because you're just sliding the picture around at that point to make it work. You're not trying to calculate for parity or do anything with parity. So you always know which one's the first drive. So if you only have 2 drives, you always know which one's the correct one. If you have 4 drives, then you just have 3 you have to swap. But since you don't have left synchronous, left asynchronous, right synchronous, right asynchronous, you've only got a choice of slice sizes. So you don't have anything else to do. You run out of things to do in like 3 minutes. And then you're like, well, it's one of these. It's one of these answers, that's it. So it really does go that fast. And I mean, you know, people sometimes seem to feel overwhelmed by it, but in the end, there's just not that many. If it's this will be like if I'm making notes and I was doing an array, and let's say I had 4 drives and I did not know what the order of the 4 drives was. I started at 64K. And again, on RAID 0, most people aren't playing with the sizes, so the most you're going to get is 32, 64, or 128. That would be the most common. And unless you're on a lessee drive, then you got to add 256 and 512. So you'll have to add those if you're doing the lessee drives. So here's your worst case scenario. These 3 have to swap. So you'll have 1, 3, 4, 2. 1, 4, 2, 3, and so on and so on. So you go through all of them until they've all rotated through. And so that's the most options that you'll have. Then, once you've done that and you got the order correct for your row, then you start making sure that you've got your slice sizes right. So you'll go 64, 128, and then back down to 32, and then I'll add these 2. If the box says lessee, it'll be easy enough to add those. But still, in the end, by the time you're done, most of the time I have 6 choices by the time I'm done with a 4-drive array. A 2-drive array, there's no guesswork at all. Here's 1, and there's 2, and that's it. And then the only other options are these. So you only have 3 chances before you actually get it done. Does that make sense to everybody? The hard part is still, I got to repair all the stuff we did at the beginning of the week. All that work applies to this. So when you do RAID, it all comes together at once. It becomes, not only do I have to do the physical, now I've got to do the logical, and I've got to do 3 times the work because I've got all these arrays that I have to stick together and then try to extract your data. So did everybody is everybody done with it? So everybody's now got an answer. You looked at the picture. I don't know what so everybody kind of has like this, 232, bam. There was almost no work involved in it. And even if I gave you 4 drives, the worst work would be swap 2 more drives. That would be the worst case scenario. Now, so after you get this far and you've gotten this content done and you figured out the configuration, I promise the other important thing you need to do is highlight it, circle it, do something, whether it be RAID 5, RAID 0. You're going to come back in a week after the client's approved something and not know what you did, and you'll have to redo the entire job if you don't remember what you did and it was complicated, and I promise you that happens. So that's why I write it down on the yellow piece of paper, because wherever I stop and I put a check mark next to it, that's the end, and then that goes with the array from there on. So that configuration will be there for Chase. If I'm here teaching class, he can go and do it if the client calls. So I don't have to worry about that from that standpoint. Now, the next thing is, this is not your recovery. Yes, I have some pictures, but this is not your recovery. So what you need to do, so is everybody at this screen? Is everybody here? If you can get here, get to this screen. If you haven't already closed this, my next thing is going to be I'm going to close this tab. So I'm going to right click and close the tab, and I'm going to go back to here. I have my answer, so I come back here to the virtual block RAID. I click on the dark block because that's where my last thing was I did. So I'll be back here and I'll see my configuration. You can also do the snipper you can just start up the snipping tool and just take a picture of this screen and be done. Or for those who don't know, you can do control print screen and then just print screen it to a clipboard and then paste it into Word or whatever. I don't care how you get a screenshot or write it down. Once you have the configuration for this, that's all you need, but that is not your recovery. Now you come over to the partition that it created and highlight the partition. So you go down one, so you've gone from your configuration to your partition. Because you now have it configured correctly, it should all work as a regular single drive. So now you can right click, and we're not going to use carving. I do not want to scan the partition unless I'm looking for deleted content. Understand that? This is a server, and there's not an individual person somewhere deleting content on it that now wants that content back. Again, it's all the existing files. You don't want the carved data. Now maybe you want to do it as a separate pass, but no one really wants to look at all that junk. There's hundreds of thousands of pieces of junk no one wants. Everybody understand? You look at the partition, right click, and say open drive files. And now you'll see it processing the MFT. So it is now building me a hard drive and all of my data out of that. Tim, good? Where you at?
I still can get the order right. But I somehow have 4 drives, right?
No, those are slices. They're just
okay,
alternating slices. You have 2 drives and they're alternating slices.
I changed this up to 128. 64. And I reordered these.
Hang on a second. Where? Highlight one of them. Oh, you're using the wrong drives. So you're in the RAID 5. You're doing the RAID 5 drives in a RAID 0, so you're using the wrong drives.
Okay.
So just make the box full size. Make everything full size. So right click and destroy those. Remove them. Right click and remove. So you didn't close the program before,
Yeah.
did you?
Yeah.
Okay, so you added back the same drives.
Right.
Open image file. Go up from RAID 5. Go up. There's another directory called RAID 0. Go up one more. Go up one more. RAID 0.
Oh, okay.
Do that one. Go into RAID 0 version 2. Now add the DD images. Add all images. Now add those 2 drives.
That's
Right. Now, I'm just going to make sure that you understand not to be confused by the fact that you now have a mixture of image files that are RAID 0 and RAID 1. You need to make sure you're using the right ones. So I've labeled them RAID 0 and RAID 0. Okay? So now, go back up to the virtual block of RAID. Destroy what you did. So right click and remove the scan file. Say remove. Now, basically we just reset everything back to nothing. Now right click here, and now only add the ones that say RAID 0. Do not add any of the RAID 5 by accident. Okay, there you go. Now apply changes immediately. Now you can do exactly the same thing. So come back over here, right scan, right and scan. And then disable all the other file systems it's not. And then you can say scan. Say go.
Did it save the JPEG?
Yep.
Okay.
Yeah, once you've set it to default, it saves it in the program all the time, but it just doesn't save all your file systems. And so this will go really quick. It'll eventually, like right around here, it'll find your 1,000 pictures. And there was no work to reassemble, and you just have to make sure you have the right drives plugged in. So, and then once that happens, you can actually reassemble in this process that I'm doing right now. This part right here is the same for RAID 5 and RAID 0. It doesn't matter what RAID you're working on. So I'm going to take a step back and do this again. So once I had figured out the configuration and I have my found files, and I have a good looking JPEG, once I'm happy with the solution, it doesn't make any difference if I'm on RAID 5, RAID 0, RAID 6, whatever I've reassembled. The answer isn't my carved files, the answer is the file system, because you will not get everything if you do not process the file system. So Where you at? What's your number?
510.
All right, that's good. Hit stop. And then you'll have extra found files. Open that up and look at a picture, and it should be intact.
Yep.
Yep.
Same page.
All right. So close the picture and get back to this. Now I need to make sure everyone understands, if you're doing this in real life and you're trying to get your stuff back, don't use these ones you made. If you have numbers, you're not correct. You've only solved the problem. That's not your answer to give to your client, ever. So right click, close. Now you'll come back to the screen. Now we don't need the extra found files, but I don't need to do the work to get rid of them. I don't care, but if you feel like it, you can remove them. What you're going to come back to now that I have the solution is the partition. You will always have a partition if you found the solution. As long as that's all intact and your RAID array isn't in bad shape, you'll have a partition, and you can always come back to it. It doesn't matter if it's Linux, if it's a Mac, HFS, doesn't matter what it is, you'll have a partition. After you found the solution, the drives will glue back together and it'll give you its original state. Then you right click on the partition and you say open drive files, and those are going to be the real MFT entries. So when I click that, it will create a structure from all of the drives together. And so now I will have a real structure. Now, here's my tip for you if you're using RStudio. RStudio isn't a forensics program, but they did something that's kind of cool like forensics has. They made these tabs across the bottom that are access time, modified time, creation time, and their database of extensions again. So if you have it on the drive, if it processed it and it's a JPEG, it'll show you the list. It'll only give you the list of ones that exist, not the ones that are in the full database. So if I come over here, I'm on real right now, so this is the real file system, and I don't want to go hunting for pictures, because here's what I'm going to do. The very first thing that I will do as soon as I figure out a RAID array is I want money. I'm not kidding you. I want my money. And so, because it's going to take me 4 more days to extract the data from a 16 terabyte array to give to the client, I will tell the client I am done. But I need to prove to the client I am done. So here's what I do. Come to extensions. Now it will give me, if it is in the list, if you see it, there is a file on your machine that is in these folders. So if you come to graphics, I will expand the graphics. And now see, I have a small subset of pictures that exist on my computer on this drive. I come to JPEGs. Here are my JPEGs with their full name. So you see all these wonderful JPEGs. I sort by size again. Same thing we did before. I find some giant pictures. These are the real names instead of the number that we had before. So if I double click on a picture, you will see the same picture, but now I have the full path. So I actually will have the content and I will have the name of the picture. Does that make sense to everything? So I have this, and there is a full path and dates and times. All of this is now correct. This is now the operating system's metadata. So this is what it would look like if I was live on the hard drive. So now what I do is I will grab a chunk of these, usually somewhere around 20 or 30. I highlight them, I right click, I recover. I don't want to go too fast. Is everybody good? So I just hold down the shift key and I highlight 20 pictures. Everybody good so far? Then I extract 20 pictures. So I'm back to my RV and my client's number 1, 2, 3, 4, whatever. I have too many already. So A, B, C. So there's my client number 1, 2, 3, A, B, C. Everybody good? Tim, you all right? You know what we're doing, right?
Yeah.
You know why I'm doing this?
So you can get paid.
Yeah, so I get paid. I'm going to send them pictures so I get paid. But I'm not just going to send pictures. I'm going to open up like Picasa or something. You can still get it, even though Google killed it. It was a product I was using years before Google bought it, and then Google started giving it away. But Picasa makes contact sheets. So a contact sheet is all your thumbnails on a PDF or something like that. And so I just make a PDF of all my pictures, and I email them a PDF. because I don't want to email them 80 megs of pictures. Does this make sense to everybody? So I'm going to extract these pictures. Say yes, 1, 2, 3. I'm going to go to where the pictures are.
Did you just leave the boxes, the default boxes checked?
The default, yeah, in the extraction process?
Yeah.
Yeah, I just left them checked, but sometimes they'll pop up and say, I'm a hidden file, or I'm a read-only, do you want to leave that? You can say yes. Everybody know what I did though? Any problems? Then I come to where my recovery is, which I put in RV, our standard recovery folder, and I sort by date so I know which day it was. Which of course I might have my stuff wrong. 1, 2, 3, 4, ABC. So here's all the pictures I just extracted. And I can see, once I'm in the folder, I have a tab that says images. So I can click images on this tab right here, and it'll go process them all for me. So I can see them. This makes sense to everybody? And so now I can actually just scroll through and say, what's the quality? Are all of these pictures good? Now, I want you to realize, so here's what Windows did for you. And Tim, this is very important for you because this is not what a Mac does. Windows has a thumbnail directory. What it does is it pre-processes all of the files in an Explorer folder. When you click on the Explorer folder, what you are looking at, that picture, is a thumbnail. It is not really the picture. What happened is in that folder there is a picture, but Windows decided I'm in thumbnail directory. I'm going to make a picture of your picture and put it in the thumbnail directory so I can display it in this little window at the size that we want it to be. So this is actually a lie to you. Do you understand what I mean? Mm-hmm. So unless I open the picture, I may not know that it's corrupt. Your thumbnail may be correct, but the picture may be corrupt later on for some other reason. But usually at this point in time, it made them from a real picture that was working, so your thumbnail's probably correct. I just want you to understand later on, they can stray from each other. Your picture could be corrupt and the thumbnail be correct. Okay? So don't trust it. I usually check them. I usually double check. Not every file, but this is the list I'm sending to the client, so I'm going to say, okay, well here's a list of all these files that I have, and I will run Picasso. I don't have it on here, but Picasso will make a contact sheet, or you can do them any other way that you want to. But each one of these pictures is 2 megs. I can't email all this to the client. I can put it on Dropbox and send them a link, but it's a lot better if I just give them a PDF they can open, and then they can see all of these little contact pictures. So, I mean, you can still do the same thing and try to print them to a description or whatever else, or print them to an Adobe PDF or something. That's step 1. I want to send them that and say, I've done your recovery, see all these beautiful pictures, I have all your files. There may be some corruption because I have 3 sectors that I didn't copy, so there may be 1 or 2 files that are messed up. So I'll give them that. I'll say, so I got 93% of your recovery. You know, if you tell them always 100%, you better know you're 100%, because if there's 1 file that's corrupt, they're going to shoot you down. So if I say I'm 99% good, I've got a 1% chance that if 1 file is corrupt, they won't say something. It may not be corrupt because of you. It could have been corrupt on the hard drive to begin with. You might not have never had anything to do with it. So, but if you say I got 100%, you better be 100%. Good? So from a perspective of a client. So this is step 1. Send it to them, get paid. Tell them to send you a RAID array. Give me a RAID array. I have 16 terabyte. Do you want me to buy 2 8 terabytes and put them on it? Do you want 2 10 terabytes? I'll go buy it. You want to send me a RAID array that's a 32 terabyte RAID array? Then I'll plug it in and I'll copy all your data over to you and I'll mail it back. That's typically, I don't usually charge anything separate. I usually include that in part of the price unless they're having me build something or do something. Then that's a whole nother scenario. Okay? So now I have to go extract the data. This is just to get my money. So now I've got this. I come back to RStudio. Now I go back to the reel. Then I right click on the root and I recover the entire root.